So now we're going to take a look at solving systems of linear equations. And a linear system of equations is a set of equations that contains two or more linear equations. And we're going to learn three different ways on how we can solve those. The first method we are going to use is solving linear systems by graphing. So, for example, I could give you two equations. So these are a system of equations because here's equation 1 and here's equation 2. One thing I highly recommend that you do is you label your equations 1 and 2. It really helps you to keep them organized. If you don't label your equations, then that makes it harder for you. You're trying to figure out, well, what was what? So be consistent and keep things organized. So I'm going to solve this system by graphing. And when I solve, I'm going to find a solution. And in this case, a solution will be where the lines intersect. So I take this first equation right here, equation 1, and I know this is in standard form, and the easiest way to graph standard form of equations is to use the x and y intercepts. So letting y equals 0 to find the x-intercept, letting x equals 0 to find the y-intercept. I did that, and I graphed my equation right there. And then I noticed for equation 2, x minus y equals 1. Well, again, it's in standard form. The easiest way to graph that is to use my x and y intercepts. So my y-intercept was 1 when, my x-intercept is 1 when y is 0, and my y-intercept was negative 1 when my x was 0. So I graph that. So I then graph those two systems, and I notice, hey, they intersect right here at that point. And that intersection point is the solution. And that point is 1, 0. So I can say the solution is 1, 0, or x equals 1 and y equals 0. So here we can take a quick look at three more examples. Here's one example we'll take a look at. Here's another one. And here's a third one. So I'm going to take a look at those. So here's another example, and this one shows my two equations. And the first equation is x plus y equals 2, and my second equation is x minus y equals 4. I used my x and y intercepts to graph because these were in standard form. You really want to use graph paper for this because then you can see exactly where they cross. I go ahead and I graph both of those equations. I labeled my equations. I find out where they intersect. I notice here they intersect right there. That means they intersect in one point. They will only intersect in one point if they intersect because they are lines. And that is my solution. The solution is 3, -1. I can check if that works because I can stick this point back into this equation. So I would have 3 plus a -1. Hey, that equals 2. I'll stick this point back into this equation. 3 minus a -1 is the same as saying 3 plus 1, and that does equal 4. So this point should work in both equations. That's what it means to be a solution. Here is another example. My first equation is x minus y equals 3. My second equation is 2x minus 2y equals 6. Again, I'm going to take and use my x and y intercepts because these are both in standard form. I graph them, and what I notice is that one line sits on top of the other. And when one line sits on top of the other, we can say that these lines coincide. We also can say that there are infinitely many solutions. There are infinitely many solutions because every single point is a solution. And what I notice is if I look at these two equations, I can see that this equation is actually just a multiple of that equation right there. Okay? I just multiplied everything here by 2. So those lines are really the same line. They coincide, so they have infinitely many solutions. And we call those equations dependent. Another example would be the equation 3x minus 6y equals 6. And hey, you could have seen it in this form, y equals -1 half x minus 2, or in standard form, x minus 2y equals 4. Either way, you can take them and graph them. Here I use the x and y intercepts. Here I also use the x and y intercepts. I graph my lines, and what I notice is that they are parallel lines. When I have parallel lines, they never intersect. They have no solution. And so if they do not have a solution, they do not intersect. They are called parallel lines. So what happens is that what we can have is only one of three choices for our solutions. Either one, we're going to have exactly one solution, and that's where the two lines intersect at one point. Our second option is that we have infinitely many solutions, and this means they are the same line, and one line is a multiple of the other and lies on top of each other. And then my final possibility would be no solutions. They are parallel lines. What I notice is if I have them in the y-intercept form, they actually would have the same slope, because if we have the same slope, lines that have the same slope are parallel lines. And so we'd say there's no solution. You can make a little zero with a cross through. It means no solution.